So I am Dr. Vijay Bhaskar Reddy, Associate Professor, Department of Chemistry. I am handling environmental science subject for you. So today we are going to discuss about the water quality parameters. So before using water for the domestic purpose as well as industrial purpose, the water must be checked various parameters. Then only we can use for the domestic and industrial applications. So what are the quality parameters generally checked for the water? So these are the physicochemical properties like a pH, ionic strength, electrical conductivity, solids, temperature, turbidity, alkalinity, hardness, color, and toxic heavy metals present in the water. These are all quality parameters checked in the water before used domestic as well as industrial applications. Now coming to these water quality parameters also categorized in three ways. One is the physical, and the second one is the chemical, the third one is the biological. So under the physical parameters is mainly pH, ionic strength, electrical conductivity, solids, temperature, turbidity, dissolved oxygen, alkalinity, hardness, color of the water. These are all parameters checked of water under the physical parameters. Now coming to the chemicals. Chemicals means what are the dissolved salts or suspended impurities, organic, inorganic. These are all matters will be checked in the chemical parameters. Is the oxygen, chemical oxygen demanding, biological oxygen demanding, synthetic organic compounds, toxic heavy metals coming under the inorganic compounds. These are all will be checked in the chemical parameters. So biological means any coliforms, microorganisms, bacteria, virus present in the water. These will be checked under the biological impurities or parameters. Now we can go each one by one elaborately discussed water quality parameters. The first parameter is the pH. pH is what is the definition of the pH means is the negative logarithm of H plus ion concentration is called the pH. So this expansion of the abbreviation is the power of hydrogen. So here is the pH is the very good quality parameter, a critical water quality parameter, because is the determine the usability of water. Either pH is lower or higher, is whatever that parameter is a very crucial for the all industries using water as a purpose. So now coming to the, because is the pH will be scale is the start with the 0 to is a 14 scale is there, in between the 7 is the neutral. So 0 to 7 is the acidic nature and 7 to 14 is the basic nature, is the alkalinity nature is there. So that is the pH scale. This pH scale will be is the invented by the one of the scientist, name is called the Sorensen. So that definition is the pH is the negative logarithm of hydrogen ions concentration is called the pH. So generally this pH in the solution we can determine by using the hydrogen electrodes. So there are different electrodes are there. So hydrogen electrode are widely used for the determination of the pH of the solution in the given solution. So generally take the first is the check for the pH of the water. Is the first is the dissociation of the water measurements using the hydrogen electrodes. So for the activity of the protons present in the water is the 10 to the power of minus 7 moles per liter. So the dissociation reaction here the mentioned H2O will be easily dissociate into the H plus ions and OH minus ions. So this is the dissociation reaction of the water. So that dissociation reaction of the water will be calculated. The dissociation constant Kw will be calculated for the water reaction. So product by whatever the products, hydrogen ion plus OH minus ions divided by H2O is the reactants by products. So this will be equal to the 10 to the 4 of minus 14. So these all information giving the water for the pH levels. So for generally drinking water, so whatever we are taking the drinking water is generally pH should be between the range 6.5 to 8.5. Generally that is the permissible pH level of the drinking water. If more than that, some of the side effects or adverse effects are coming. Below that also, whatever the 6.5 below also, is some of the adverse effects are coming, because it's the more acidic nature or more basic also not suitable for the drinking purpose. That's why as for the BIS means Bureau of Indian Standards. Bureau of Indian Standards. The drinking water should be pH ranges between the 6.5 to 8.5. Now coming to the second, whatever the pH scale here given, what affects is the pH values are given from the 0 to 14. In between the 7 will be a neutral condition is there. For example, when here the some of the environmental effects given the acid rain. So acid rain is coming from when the sulfur present in the coal sample. For example, in the thermal power plant, coal will be used for the power generation. That sulfur is converted to the combustion reaction to convert the sulfur dioxide. So means this sulfur dioxide is coming to in the environment or atmosphere. So in the atmosphere, lot of humidity and moisture will be there. In the atmosphere, lot of moisture and humidity will be there. These two combined, whatever the gases, and these two will be combined. Immediately acid is fall down. Acids will be, that is called the acid rain. So once that acid rain pH nearly 4.2 to 4.4 will be there. 4.2 to 4.4 will be there. So if the acid rain is enter into the water bodies like a aquatic or marine system, that water will be, acid rain will be enter. Most of the all fishes will be died at the pH of 4.2 because is the that will be not survived at the pH. Because the more acidic nature is there. So for example, if the another example given when the frog eggs, tadpoles and larvae, these all will be mostly growth in the basic conditions. Basic conditions means nearly pH is a 9 to 10.5. That pH, these all will be grow more fastly compared to the acidic nature. For example, any organic matter like plants, waste, peels, these are all will be coming into the water bodies. So that water bodies pH will be coming down because is the dirt organic matter release a lot of acids related compounds into the water, that pH will be reduced. So once the pH reduced, these are all eggs, tadpoles, larvae, whatever the reproduction, these are all will be damaged at the pH of 4.5 or 5.5 to 6. So another one of the example, this also at the pH 6, whatever the some of the fishes also is dead because is the environmental effect will be takes place. So these are the some of the pH scale related. So now coming to the second water quality parameter is the ionic strength. This is also very important, ionic strength. So generally when the chemicals will be dissolved, for example, a sodium chloride will be dissolved in the water. The sodium ions and the chloride ions will be there. So that ionic strength we can determine in the given water sample. So these are the measure the concentration of the cations and the anions. Whatever the cations present or anions present in the water sample, concentrations will be determined, that is related to the ionic strength of the solutions. So this is the property of the solution, not a individual ions, because is the solution means combined the both anions and cations, not of individual ions. So once both will be measured, that is the property of the solution only. So this is the first ionic strength is whatever defined by the one of the scientists is the Lewis and Randall in 1921. So that will be calculated by the equation is equal to ionic strength equal to the half of the sum of Ci and Zi square. Here the whatever the terminology, I means whatever the ionic strength. I is the ionic strength. This is the sum of the Ci. Ci means concentration of the any ion, whatever the is the cation or anion, whatever the concentration of that one. Zi means is a charge of any ion, charge for whatever the valency is there, either +1 or +2, +3, +4, whatever is the charge is there on that cation, that will be represented as the Zi square. So based on this, using the formula, you calculate the ionic strength present in the given water body sample. So here the ionic strength calculations requires complete characterization of the water sample for individual cation and anion, which we generally determined by the one of the instrument like the ion chromatograph. So using the ion chromatograph, this whatever the ionic strength can be determined in the water sample. So this is the quality parameter of the ionic strength. Now coming to the electrical conductivity. Electrical conductivity also a very important water quality parameter, is based on the related to the sum of the relation between the ionic strength. So generally it is measures the concentration of all ions present in the water sample, either cations or anions, whatever, or deuterions, whatever ions present in the water sample, that will be measured is the electrical conductivity. So the units for the electrical conductivity measured are microsiemens in a centimeter. So generally Siemens or microsiemens will be used in a centimeter. So inverse of the whatever the electrical conductivity, inverse of the electrical conductivity is called the electrical resistance. So electrical resistance means inverse of the electrical conductivity. Electrical conductivity is called the electrical resistivity. So this electrical resistance means generally resistance will be, units are used, ohms or mega ohms or micro ohms, whatever that one, in centimeter. So generally these are all will be carried out at the room temperature like 25 degrees centigrade. So this directly influencing the strength of the ionic strength of a solution. So this conductivity, whatever the conductivity is measured in the field of science, instantly using the sum of the probes or pocket or portable machinery will be used like that one. So because in that one some directly probe will be inserted like electrode like that one. So once that will be inserted in the water sample, that will be giving the how much is the electrical conductivity is there. Is a portable or pocket size probes are came nowadays to determine the electrical conductivity. So this conductivity and TDS means total dissolved salts present in the water. Total dissolved salts present in the water, that will be a directly proportionate and to be expressed under conductivity and total dissolved salts. When the total dissolved salts are more, is the conductivity also is increased, because is the those ions will be represented in the conductivity. So means is the total dissolved salts so directly proportionate can be expressed as is the TDS, total dissolved salts in mg per liter, equal to is the A multiplied with the conductivity. Here is the A is the one of the constant, is a conversion factor ranging from the 0.5 to 0.75 milligram centimeter per liter. So conductivity is whatever is directly related to the TDS, total dissolved salts. So now we can go for the another parameter in the water quality. We discussed that one is the solids. So this is the very important parameter for the determine the water quality parameter. So now coming to the total solids. Total solids means whatever all solids, either organic or inorganic or metals, whatever, these are all coming under the category of the all solids dissolved. So some of the salts will be dissolved freely in the solution or solvent. Some will be suspended, not soluble. Some will be not miscible or is a suspended. All solids, dissolved salts and suspended impurities. So total solids are further divided into a few categories. So first one is the total suspended solids. Total suspended solids, how you can define in the given solution means the water quality measurement, the total solids, suspended solids are defined as, for example, when a membrane will be filter will be used. This is a membrane filter, for example, a membrane filter. When the solution, whatever the solids, all solids are separated. Whatever present in the solution, all solids are separated by using the membrane filter containing the micron size 1.52 is a 1.7. So for example, this membrane filter size will be 1.5 to 1.7 is there when the all dissolved salts, whatever the suspended solids present in the solution will be separated, is called the total suspended solids. So whatever solids will be separated by using the membrane filter, the size will be the 1.5 to 1.7 micron pore size. So once using this size, the total solids will be separated from the solution. That solids are called the total suspended solids. So for example, total dissolved solids. What is the definition of the total dissolved solids? For example, when the solids to pass through the above same membrane filter will be passed. But most of the solids will be passed through the membrane filter, but some of the solids remaining in the filtrate, those solids are called the total dissolved solids. That category is the total dissolved solids. So once the same solids will be passed through the membrane filter containing the micron size will be 1.5 to 1.74 size, that whatever the solids will be passed, some of the remaining solids will be left remaining in the filtrate. Those solids are called the total dissolved solids. The next category is the total fixed solids. Total fixed solids means when the total solids, take the total solids quantity, so that will be burned at the temperature of the 550 degrees centigrade in a muffle furnace. Because we are taking the higher temperatures, means we must use the some of the furnaces only. So we are using the muffle furnaces. The residue remaining after burning at the temperature 550 degrees centigrade is called the total fixed solids. So finally, the total volatile solids. What are the total volatile solids here? Here the sum of the difference between the previous definitions. The difference between the weight between the total solids and total fixed solids is represented as the total volatile solids. So the equation between the total solids and the total fixed solids and the total volatile solids. This is the relation between the three solids. So total solids and the total fixed solids and the total volatile solids. Now coming to this is the schematic representation of the previous explanation. Total solids will be divided into the different categories like a total suspended solids, total volatile solids, total fixed solids and a total dissolved solids. The previous slide only is the representation through is a schematic diagram. So now coming to the another water quality parameter, that is the temperature. Here the temperature is a very crucial role play the water bodies. Affected the water bodies because is the water containing the so many dissolved salts, dissolved oxygen levels and biodiversity of any ecosystem. For example, without water, any ecosystem is not survive. So the extent of the rate of the all physical, chemical and biological process are temperature dependent because is the water containing the lot of salts will be dissolved and dissolved oxygen, biological oxygen demand, some of the chemicals will be dissolved. Once these are all present in that water, is what temperature will be dependent. If the more will be dissolved, more temperature will be required. So means here the factors influence the water temperature, unpolluted surface water bodies like a light intensity, turbidity of water and ambient temperature. So now coming to the temperature of water quality parameters like a density of water. For example, a density will be more. Density is the temperature will be affected differently. Is the dissolved oxygen concentration. If the, for example, dissolved oxygen is a more required for the aquatic life. If the more temperature is there, this dissolved oxygen will be easily evaporated. So means if the temperature is more, is the dissolved oxygen will be slowly reduced and aquatic life will be affected. So that is the relation between the temperature and whatever the dissolved parameters, dissolved substances in the water that will be affected the environmental or aquatic life. Solubility and dissolution of various contaminants. If the more contaminants or more solubility is there, some of the salts, that temperature will be different. So affected the parameter different. So organisms will be grow some of the temperatures. So volatilization of the contaminants and the temperature is increased, some of the volatile compounds also increased. So means whatever parameter, water quality parameters, the temperature is effects will be different. That will be affected the water quality bodies or aquatic life or marine environment. Now coming to the turbidity. Turbidity is also very important a parameter determined for the water quality. So here the turbidity mainly indicates the presence of light scattering substances in water. For example, light will be scattering substances. If more salts, more substances will be dissolved in the water, light will be scattered the substances in water. That will be associated with the particle sizes like a clay gani, for example, clay, silt, some of the biological particles like a bacteria, algae. These are all influence the turbidity related to the water parameters. So here the, for example, high turbidity level is there. For example, a water sample containing the high turbidity level is there. Water sample containing the high turbidity. What happen is a light from penetrating deep into the water sample. So once the more turbidity is there in that water sample means that light will be more penetration inside the water bodies. So means at that time is the shallow the photoic light zone will be created. If the water sample will be more turbidity is there, means more penetration of the light will be passing through that one, is one of the shallow photo zone will be created. In that place more aquatic life will be growth. So for example, photosynthesis organisms are capable for growing only in the photozoic cone only, because is the more light will be passed through that water sample, and automatically is the food will be prepared in the aquatic life. So another one is the aphotic or darker zone. So darker zone means some that water will be not passed or not penetrating through the water sample. In that place, if aphotic is a darker zone will be created. In that place is the aquatic life, whatever is the plankton cannot be sustained their growth, because the light is not passed through the dirt solution or whatever is the water bodies is not sustain their growth. So this results in the lack of the oxygen generation in the aphotic zone, because is the lack of oxygen also is one of the parameter for the aphotic zone. Therefore is a dissolved oxygen levels will be zero in that one. So generally this turbidity, whatever the turbidity will be determined, one of the instrument will be used, that is called the turbidity meter or nephlometer, used to determine the how much turbidity present in the water sample for the this aquatic life and marine life. So here the generally what are the units are used for the turbidity means NTU units. NTU units means nephlometric turbidity units. These are units generally expressed of the turbidity present in the water sample. Is another one is the alkalinity. This is a very important parameter checking before you can use the water bodies, either domestic purpose or industrial applications, is the alkalinity. So alkalinity means how much capable of the neutralization capacity of the water or buffering capacity of the water sample by standard acids is called the alkalinity. So generally this alkalinity is causing for the different salts present in the water or dissolved in the water, either carbonates present dissolved in the water or bicarbonates or hydroxiles, along with some of the phosphates, silicates and sulfates also responsible for the alkalinity present in the water sample. Majorly these carbonates, bicarbonates and hydroxyls are major responsible for the alkalinity present in the water sample. So once these salts will be dissolved in the water sample, so that pH levels will be increased. For example, a high alkalinity water will be taken in the boiler for the power generation or steam generation. So in that boiler will be lot of a corrosion will be takes place because is the more alkalinity present in the water sample. So that's why you must check before we can use the water sample, that is domestically as well as industrial applications. So for example, this will be determined by the total alkalinity, carbonate and bicarbonate alkalinity. So different categories based on the dissolved salts present in the water sample. So another important parameter is the hardness, water quality parameter. So generally this is causing for the hardness majorly is the bivalent metals of calcium and magnesium. Some of the metals also responsible for the hardness present in the water. If the more salts will be dissolved in the water, is lather will be not produced, and some of the scales and the sludges will be arise due to the boiler troubles will be arise in the industrially due to the steam generation. So here this hardness will be expressed in terms of calcium carbonate equivalents in the magnesium milligram per liter. So here is there are two types of hardness is there, temporary hardness and permanent hardness. Temporary hardness is also called the non-carbonate hardness. Carbonate hardness is a permanent hardness is also called the non-carbonate hardness. Is a permanent hardness is the chlorides, sulfates and nitrates of bivalent metals, and the temporary hardness is the bicarbonates and of the bivalent metals. So generally is the whatever is the desirable limit for the total hardness required, that permissible limit for the water sample is a 200 mg per liter as per the BIS norms, Bureau of Indian Standard norms. So now that is the total hardness. Now coming to the color. So generally color of the water is due to the presence of dissolved or particulate matter, may be either organic or inorganic. For example, some of the organic compounds will be dissolved in the water sample, the color will be generated. Some of the organic matter also dissolved in the water, slowly color will be coming out. For example, here the organic matter like some of the humic acid, fulvic acids present in the organic matter, plants and animals, that will be slowly released into the water bodies. So water bodies color will be changed, like a yellow color or like a tea color will be coming out. When the phytoplanktons, like a algae, fungus, like a small plants will be release some of the color, that is either green or yellow color to the water. Some of the inorganic material like iron, manganese and chromium present in the water sample, this will be easily oxidized in the conditions, that will be color also change, water color will be changed. Sometimes yellow to red to yellow is coming. Some of the metals like precipitated and oxidized, that color will be changed. So here the measured in terms of color, whatever coming to the either organic matter or inorganic matter or oxidized metals present in the water bodies, that measured in terms of ASN units or platinum cobalt units. These units we can represent the how color present in the water sample. So here the one of the definition is there, the color produced 1 milligram of the platinum cobalt dissolved in 1 liter of the water in a fixed unit of color and a platinum cobalt scale. So here the Hazen units are using for the measure the whatever units color present in the water sample. So today in this presentation we discussed about the water quality parameters. So water quality parameters: hardness, alkalinity, ionic strength, electrical conductivity, like a pH, like a total dissolved salts. These are all parameters discussed on thoroughly. So in the next lecture we discussed about the water pollution. Thanking you.